Solve the equation analytically. Write the answer in exact form. Here we have a logarithmic equation with multiple logs, some on the left, some on the right. In general, when you have a logarithmic equation, some terms might not have a log and some terms will have logs. Move all the log terms on one side and anything without a log term on the other side. So what that would look like here. Now this isn't the only way to solve this, but it's a nice consistent approach. So we have 2 log base 9 of x minus log base 9 of 4 minus log base 9 of x plus 8 equals 0. Now combine all the logs together. So this includes like bringing exponents up and making positives multiplication, negatives division. This is all log base 9 of x squared over 4 and x plus 8. The 4 is a negative log. It goes in the denominator of the combined log. The x plus 8 is the abscissa of a negative log. It goes in the denominator of the combined log, etc., etc. Once you've succeeded in getting all the logs on one side combined into one log and anything without a log on the other side, you can now just convert to exponential form. I'm going to take a big 9 of both sides. That gets rid of the log. And this leaves us now with a new type of equation. X squared over, I'm going to spend a bit of time to distribute those, 4x plus 32 equals, now 9 to the 0 is 1. We're dealing with a rational equation now. We've gone from a log equation to a rational equation. Clearing the fractions, multiply by 4x plus 32 on both sides. This is an equation, so I don't have to worry about switching inequalities or anything, so there's nothing mischievous about this step. X squared equals 4x plus 32. Okay, looking good, looking good. This is now a quadratic equation or a polynomial equation. We can solve that by moving it all to one side and seeing if we can factor. In this case, 8 times 4 is 32, adds up to 4. X minus 8, x plus 4 equals 0. And we get two potential answers, x equals 8 and x equals negative 4. These are the solutions of the quadratic equation, not necessarily the solutions of the rational equation or the log equation. So we need to check them back at the original. Like 8. For the check, if I plug in 8, I would get 2 log base 9 of 8 equals log base 9 of 4 plus log base 9 of 8 plus 8 is 16. Is that true? At least there's nothing inherently wrong with this. Now take a look at the other one. I shouldn't have put that one in red. Should have put that one in green because the other one was the other answer, negative 4. If we try this, we get 2 log base 9 of negative 4 equals, oh, that's already enough. That doesn't exist. Negative 4 is not in the domain of any log function. I shouldn't say that. Negative 4 is not in the domain of this log function. Now, it remains to be seen if the left one is correct. We could do things like this 2 goes up there, 64. This turns into multiplication of logs. 4 times 16 is 64. This one does work correctly. So our answer is x equals 8. So, interesting, this went from a log equation. Logs have domain issues, so we need to check our answers for sure. Changed to a rational equation. They also have domain issues. We definitely need to check the answers. Changed to a quadratic equation that ended up changing to nice linear equations. We have our answers and we checked. Hope this makes sense.